Hello, everyone. Thank you for joining us here today for our webinar where we are going to cover AERSURFACE, both what AERSURFACE is, as well as recent updates made to the AERSURFACE tool and how you can utilize those within Lake's Environmental Software's AirModView product. And let's get our base started with what is AERSURFACE. Well, it is a tool developed by the United States Environmental Protection Agency, and it helps calculate surface characteristics from digital land cover data. Reading in these digital land cover files, it uses some lookup tables to associate each of the digital land cover categorizations into three different surface characteristics. The first is albedo, which is a measure of reflection, specifically how much of incoming solar radiation is reflected by a specific land use category at the surface. Next is the Bowen ratio, which is a measure of dryness in the planetary boundary layer, again, a function of land use category. And both albedo and Bowen ratio are very integral to AirMod's calculations of convective turbulence within the planetary boundary layer. The third surface characteristic is surface roughness, and that's a mechanical turbulence feature based on the average height of a blocking object that can deter the wind. The tool itself is recommended, not required, by Appendix W, also referred to as the Guideline on Air Quality Models, but the methodology incorporated within AERSURFACE is required to be used for calculating these surface characteristics. So it is a useful tool for objectively calculating these parameters. It has reproducible results, which is of course beneficial to everyone involved with a particular modeling project. And so while the tool itself is only recommended, it also makes your life much easier. Now, the original version of AERSURFACE was released in January of 2008 with the version number 08009. It was subsequently updated in January of 2013. And these versions could only read the NLCD 1992 format files, NLCD being the acronym for the National Land Cover Database. These files, of course, being a bit dated to where we are now, where most modeling is conducted with more recent years of meteorological data, and also the spatial extent of these files was limited. You could only get the NLCD 1992 data for the contiguous or lower 48 United States. Now, the calculations within AERSURFACE, as I mentioned before, are required to be used for calculating surface characteristics. This includes for surface roughness an inverse distance geometric mean from a 1 kilometer radius around the Met Tower. You can divide that up into as many as 12 sectors in order to get more spatially congruent categorizations within each sector. And the Bowen ratio and albedo are weighted averages. Bowen ratio is a weighted geometric mean. Albedo is an arithmetic mean within a 100 square kilometer square area, again, centered on the Met Tower. So you would do a 10 kilometer by 10 kilometer block. Now, earlier this year, back in February, there was an update made to the AERSURFACE tool. It was dated 19039_DRFT, so it is a draft release. It is not currently approved for regulatory use within the United States, but it was released for testing, review, and comment by the modeling stakeholder community. And it incorporated a number of long-time plan changes to AERSURFACE, the most important of which is that instead of just the 1992 data, you can now use 2001, 2006, and 2011 land cover data in GeoTIFF format. This expands the capabilities of AERSURFACE far beyond the original, not just because it brings newer, more representative land cover data into use, but it also expands the spatial extent into Alaska, Hawaii, and Puerto Rico. Now, for current users of AirModView, you'll note that if you are not in the United States, you can still utilize AERSURFACE by way of Lake's Land Use Creator utility, which extends support of AERSURFACE to non-US locations by way of creating GeoTIFF image files with the NLCD land use categorizations that can be then input to AERSURFACE regardless of where they are located. Another big change within this version of air surface is that the calculations are refined through the use of supplemental canopy and impervious data that go along with the land cover NLCD data. Another addition to 19039 draft is a new roughness calculation method referred to as ZOF, or the effective roughness methodology. This is a research-grade beta enhancement to air surface, which was incorporated so that people could perform additional tests on it and hopefully validate it more so that someday it could be considered for regulatory use. There was also a new input control file format added. For those of you who are very familiar with AirMod, it will look familiar to you because it uses the same pathway keyword structure that the existing models such as AirMod, AirMap, and others already use. Now within the NLCD data, as I mentioned, the new air surface allows use of 2001, 2006, and 2011 data. These categories are a bit different from the earlier 1992 classification system, as you can see here. Very close, but not quite. There's just a few subtle differences. The 1992 categorization used 21 categories, and some of those were consolidated for the 2001, 06, and 11 sets. One of the big changes that you may see is right here. Category 85 in 1992 was urban recreational grasses. And when you have Met towers placed at airports, there's a lot of urban recreational grasses around them because you tend to have fairly flat land where you place your airports. This has somewhat transitioned into the new Category 21 developed open space. And you may notice some other categorization changes as well, such as the consolidation of small grains and fallow and row crops into a single category of cultivated crops in the newer 01, 06, 11 set. We also have changes in what was categorized in 1992 as low-intensity residential, high-intensity residential, and commercial industrial transportation, 21, 22, and 23, have now become these larger catch-all developed categories, which are classified by percentages of man-made materials within each segment. If you look through the EPA's air surface documentation, you can see how they modified their lookup tables of albedo, Bowen ratio, and surface roughness to fit the new classification scheme. The other big change with Canopy and Impervious data allows the calculations to be refined. So the Canopy and Impervious data sets are the percent of each 30-meter resolution grid cell, which is covered by a man-made surface or by tree canopy. By understanding this information, AERSURFACE is able to refine its calculations of surface roughness by first saying, yes, the data is supplemented with impervious and canopy data. It then decides, based on user input, if the sector used for surface roughness calculation is an airport sector or not. If it is, it uses some flatter land use types, such as the old urban recreational grasses values and the bare rock, sand, and clay to determine what is impervious versus high-intensity residential and mixed forest for the canopy. If it is not an airport sector, it relies more on that high-intensity residential and mixed forest for the canopy and impervious, respectively, to determine the surface roughness. So if it's not an airport sector, you get a slightly higher value than if it is an airport sector, where it's assuming that the percent impervious is mostly flat runway as opposed to actual structures.